Welcome to Geology 1303, Introduction to Geology. Last time you will remember that we were talking about metamorphic rocks. We talked about the effects of pressure and temperature on rocks, which changed their composition to produce minerals that were stable under the pressure and temperature that were there. We talked about the classification of metamorphic rocks into foliated and non-foliated. Today we're going to start with a new unit on structural geology. Structural geology is the study of how rocks deform on the Earth's surface. At this point, I would like to move to my PowerPoint presentation. I would like to start my discussion on structural geology with this image of the Virgin Anticline in southwestern Utah. Note that the rocks here are not horizontal, that they're dipping off in two different directions. This is very typical when rocks are affected by stresses on the Earth's surface and they deform due to those stresses in a plastic manner. When we talk about structural geology, we're talking about the study of the architecture of the Earth. We're talking about how bedrocks are taken from a horizontal position and deformed in one way or another. In the upper image on the right, you see a beautiful fault that has deformed the rocks. In the lower left, you see where the rocks have been deformed in a very ductile form to produce the folds that you have there. These relationships are what we're going to be discussing in structural geology. In structural geology, we have three different types of deformation. We have brittle deformation, is where the rocks break. We have ductile deformation, where they're deformed as a soft plastic. And we have elastic deformation, where the rocks are deformed and then returned to the shape that they're in. This deformation is caused by stress. We have three different types of stress that we're looking at. We have compressive stress, where you have the two stress vectors coming together parallel to each other. We have tensional stress, where the two vectors are pulling apart parallel to each other. We have strain, where the vectors are not parallel to each other and cause the rocks to slip past each other. Stress results in strain of the rocks. Strain is the adjustment of rock to the stresses that we see, to compressive stress, tensional stress, and shear stress. In strain, we have three different types of strain. We have plastic strain, where the body is molded or bent. We have elastic strain, where it bends and returns to its original form. And we have brittle strain, which usually results in the fracturing of rocks to produce faults. In conclusion, I show you this image of Maple Mountain, which shows what the stress on rocks do and how the rocks have reacted with strain. In this segment, we talked about brittle deformation, which means the rocks break. We talked about ductile, which means the rocks bend as a plastic. And we talked about elastic, where they would bend and then return to their position. Stress is the force that is placed on the rock, and strain is the way in which the rock reacts. I thank you for joining me.